Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Students, in this video, we will be discussing about question number 26 of NEET Physics paper 2015. Let us solve question number 26. A particle of mass m is driven by a machine that delivers a constant power k watts. Particle of mass m is driven by a machine that delivers a constant power is constant and नीचे रख देता हूँ.
Ready? Start.
So machine delivers a constant power k watts. This constant and its value is k in terms of watts. Is a number. It's given as k. If the particle starts from rest, so its initial velocity is 0. If the particle starts from rest, the force on the particle at time t is at any time t. So force as a function of time we have to find. First of all, to have the relationship among this force and as a function of time, we must know how this power and this force, that is instantaneous power and instantaneous force, are related. We know that the power is work done by time, the rate at which the work is done. So work done is the force, the dot product of force and displacement velocity vector, because work done is F dot S divided by T. From here S by T becomes V, so this power, instantaneous power, is F dot V, which is a constant. So F dot V is a constant, so I'll write that F dot V is MA dot B is a constant, and that is K. P's value is K. So from here that implies MA is dV over dt. Acceleration is dV over dt, and this V is K. Now, if I write this properly, then this will become V dV is K dt over M. This expression. Now, to get the value of F as a function of t, I write F is mass into acceleration. I write this force as mass into acceleration, so I want to write acceleration as a function of time. To get the acceleration as a function of time, I have to find this V as a function of time. Then the process is to find A as a function of time. I will find first V as a function of time, then differentiate this, and I'll get acceleration as a function of time. So if I take integration, then what I'll get? What is that integration? The integration, if I take integration, I will have starting from 0 velocity to any velocity v, and this time is time t equals to 0 to time t equals to any time t. So when the time is t, the velocity is v. So this becomes v square by 2, and that equals to k by m comes out, and it is t. So from here I'll write that this v equals to 2kt over m under root. This is the velocity. This velocity I'm getting as a function of time here. If I differentiate this equation, then this is my acceleration. So these are the steps. So if I differentiate this equation, dv over dt, which is my acceleration, is differentiation of this with respect to time, which is 2k over m under root comes out. Root t is 1 upon 2 root t. So from here, I am getting a. So this force is mass into acceleration, that is mass into this value is what is acceleration. So this is 2k over m, this one. Now this m, if I have to see the options, then everything is inside, only this t is outside and 2 is outside, so everything inside. So m is taken inside, then this m becomes square and 1 m is left behind. So this is 2mk. Now this m will cancel out, and this is 1 over 2 root t. Now from here what I will get, if I see the options, then t to the power minus half is everywhere there. So this is t to the power minus half, but if I keep this 2, then this 2 will there. So both the 2's are not there in any expressions. In any expression both the 2 is not there, so any 1 2 I will keep. So if I write this, then this will be root 2 into root 2. This root 2 will cancel, so here it will be only mk root, and this root 2 cancels, so it is t to the power minus half. Okay, and because of this 1 root 2 will remain, because this is root 2 root 2, so 1 root 2 will remain, so I can write this divided by 2, 1 root 2 will remain. So that's the root 2 can be taken inside, and it's the same thing. So this is what I am getting, that is mk divided by 2 under root t to the power minus half. So this root 2 is there, k by this root 2 is there, and mk is there, so mk by 2 whole root and t to the power minus half. So therefore this option number 3 is correct answer to this question. So basically from power you write the general expression of power in terms of force, velocity, and then from velocity you get the expression for velocity as a function of time, then differentiate it to get the acceleration, and multiply by mass to get the force. Okay, thank you.